Welcome to the SyncSort Real Applications video series. Today we introduce a graphical approach to offload data processing to Hadoop. Moving data and processing to Hadoop is often associated with the need for highly skilled programmers in Java, Hive, and other Hadoop technologies. There is an alternative, a comprehensive graphical approach. No need to write thousands of lines of code. This approach accelerates offloading your Enterprise Data Warehouse, or EDW, and other source systems such as Mainframe to inexpensive Hadoop storage and processors. Now our data integration expert will demo a real customer scenario using SyncSort DMX-H.
This happens to be a retail pharma data offload. The basic description is business rules that need to be run on pharmacy data and retail data. The overall goal is to make sure that the organization is able to have more targeted information on the customer so that they can have more targeted marketing campaigns from a pharmaceutical perspective. So what does this involve from a technical perspective? If you look at the third bullet, it involves two joins and an aggregation or a group by from a ETL or a data transformation perspective. You might all be aware of high volume joins and aggregations being the classic use case to offload from a data warehouse. So let's take a look at the actual use case from a graphical perspective. On the left, you have Oracle EDW Enterprise Data Warehouse. You have the actual cluster that's CDH, and you have 12 nodes on the cluster, and you have DMX-H running on every node in the cluster natively. This is a huge differentiation for the DMX-H product. And so it is important to realize there is no code generation, there is no requirement to have any sort of tuning and any sort of coding involved when it comes to using DMX-H. It is the native engine that runs in the cluster, and everything is graphically deployed on the cluster. On the right, you have the Oracle data warehouse that is being loaded again after the MapReduce is done. The MapReduce is actually being done by deploying the graphical job, which involves the two joins and the aggregation. So let's take a look at the actual PL SQL that I was able to convert from what it was in the EDW to what it is in the CDH cluster. I'm not going to go into the details of the PL SQL, but I'll tell you that there was a lot of aggregations and minimum functions and so on, and there was a total of 988 lines of PL SQL code. If I go all the way to the top and all the way to the bottom, you can see there's a lot of code. This is obviously a lot of maintenance and a lot of coding, and I'm going to show you what that looks like in DMX-H in MapReduce. It's extremely simple. So that's what the 988 lines of code looks like. If you're not familiar with DMX-H, you're looking at the job editor. The job editor is basically the workflow, the overall flow of various steps in the MapReduce sequence. The first one you're looking at is a subjob, which is doing a join. The second one is doing a combination of a join and an aggregation or a group by. What's happening here is a very simple two-step process to achieve what you have in what PL SQL is doing. Highly graphical, and if you actually drill into one of these, it'll show you how the MapReduce sequence is set up, and you can see there is a MapReduce link in between, and everything to the left of the MapReduce link is the map task or the map logic, and everything to the right is the reduce logic. So it's all graphical. There's no Java coding, there's no Java code generation, even at runtime. And if you dig into the next subjob, it also has a very similar approach. Not only are we doing a join, but we're also doing an aggregation. So it's important to realize that in the MapReduce paradigm, a lot of times you would need to, if you use Hive or other technologies, in Hadoop, you would need to have 3 or more steps or 3 or more MapReduce jobs. In DMX-H, you're able to actually have much less number of jobs, including the fact that I am able to do a join and aggregation in the same subjob and in the same reducer. And if you notice, there is a very simple way to pass data between the join step and the aggregation step or the group by step using a direct flow. And the direct flow basically means that you're not landing data into any sort of temporary files.
Let's briefly compare the runtimes of PL/SQL on Oracle to Hadoop ETL with SyncSort on 6-node and 12-node clusters. In production volume itself, the jobs ran on 6 nodes for 23 minutes, and as you saw in the demo, on 12 nodes for 12 minutes and 34 seconds, versus 2 hours and 40 minutes with PL/SQL. Increasing volume to 2x of production, Hadoop ETL runtimes were just 6% and 3% respectively of 780 minutes with PL/SQL. Then, we took one step further, which we were not able to do on Oracle. Running with 5x of production volume, resulting times were still lower than PL/SQL in actual production. This is the ability of SyncSort Hadoop ETL, to take nearly 1,000 lines of a PL/SQL program and convert it to 12 minutes in a day or so. The highly busy data warehouse required a lot of tuning with PL/SQL. There was absolutely no tuning with Graphical Hadoop ETL. So, we avoid writing to HDFS a very large volume of data processing in literally billions and millions of rows, thereby freeing up valuable Oracle data warehouse capacity with offload to Hadoop. So there you go. In today's example, we showed a fully automated graphical approach for EDW offload to Hadoop. No Java or other coding skills needed for existing ETL developers to use the highly optimized, fastest ETL engine to develop complete data flows for advanced analytics. To learn more, go to syncsort.com. Thanks for watching.